Hey guys, it's now time to step away from the comfortable world of arithmetics into the more fascinating arena of algebra. We're now going to deal with variables, expressions, and equations. And in this lesson, we're going to get an introduction of linear equations, and in particular, start the exploration of linear equations in one variable. Let me give a few preliminary points.
Note 1.
Firstly, you may have also heard of things like quadratic equations, cubic equations, biquadratic equations, as well as linear inequations or linear inequalities, and so on for quadratic. These are things that are slightly more advanced, and we will get to them at some point. But I just want to let you know about their existence so that you know that linear equations is the foundation of algebra, and it is important to develop a command on this topic.
Note 2.
Secondly, when we deal with arithmetics, we usually have concrete numbers, more technically referred to as constants, like 23 plus 5 or 2 into 7. You can evaluate that, of course, as 23 plus 5 equals 28 or 2 into 7 equals to 14. But there is something called as a variable. A variable is a quantity which can take on different values depending on the context of the problem. So it varies, it changes based on which question, which equation you are talking about. You can denote a variable using pretty much anything you fancy. We usually use x or y or alpha or beta or any preferable English or Greek alphabet of your choice. But let me show you what I actually mean by a variable being capable of taking not one fixed constant value, but a variety of them. So if I tell you the expression x plus 3, now x can take on any value. So if you say x equals to 0, then this expression would evaluate to 0 plus 3 equals to 3. If you were to say let x be 1, then this expression would evaluate to 1 plus 3 equals to 4. If you were to randomly assume x to be, let's say, 10, then this expression would evaluate to 10 plus 3 equals to 13. So there is virtually no constraint on what value x can take whatsoever. But if I told you about the equation x plus 3 equals to 5, then x can't be 0 or 1, but you can solve this mentally that if x is 2, that is when the left hand side becomes x plus 3, 2 plus 3, 5, and satisfies the equality to the right hand side, which is just 5. So there is a constraint, which is to say that x can take up only one value, that is to say 2, for this equation. But if I give you another equation, x plus y equals to 5, x and y are both variables. Then if you say x is 0, then y must be 5 so as to satisfy x plus y equals to 0 plus 5 equals to 5. You could say, no, let y be 0, then x would need to be 5, and that would also satisfy this equation. So there are an infinite pair of values that x and y can take, and there is again virtually no constraint on what that could be at all. I know a lot of students feel intimidated by the concept of variables when they are new to algebra, but if you were to ask me, constants are what feel limiting, rigid, and stubborn. Variables, on the other hand, are flexible. You can bend and stretch them at will, and that's where the fun stuff comes in. Moving back to linear equations. Let's break this down into two parts, linear and equations. To understand an equation, we need to understand what an expression is. An expression is the statement of a bunch of values. For instance, 5 is an expression. 10 upon 5 is also an expression. X plus 3 is an expression too, made up of a variable and a constant. Y plus Z is an expression as well, which is made up entirely of variables. What an equation does is that it sets two expressions as being equal to each other. So there is an expression to the left, an expression to the right, and equals to sign between them, and an equation is claiming that the left hand side expression is equal to the right hand side expression. Let me give you a bunch of random examples. 1 plus 1 equals to 3 minus 1. X plus 10 equals to y plus 20. X plus y equals to 5. All of these are valid forms of equations. So think of it this way, an expression is like a swing. It's independent, you can do whatever you want to with it. However, in case of an equation, it is more like a seesaw, wherein there are two sides to it, two people sitting on it, and you need to ensure that there is a balance, synchronous, and harmony between both. What does linear mean? I won't be able to go into great detail on this one at this point. What this essentially means is that when you plot the graph of any linear equation on the coordinate plane, what you get is a straight line, not something curvy, not something irregular. We will be understanding why this happens more when we get to the graphical representation of different equations and formats. But for now, I hope you can accept this as the truth without much explanation. For now, let's just deal with linear equations in one variable, the simplest of the lot. The general form of a linear equation in one variable is, and I want you to remember this, a into x plus b equals to 0, or alternatively, a into x equals to b, where a and b are some constants, whereas x is a variable. Now, a and b can be positive, negative, fractional, but they must be constant values and will be given in the question. However, x is the variable which is usually the thing around which our questions will revolve. You can of course say y or z or alpha or beta and use those to represent the variable, but I am saying a into x plus b equals to 0 or a into x equals to b just for standard's sake. No rule as such. While it is probably more important to be able to solve linear equations and find out the value of a variable, it is equally important to be able to identify what is and is not a linear equation in the first place. So let us now do some practice questions on identifying which of the following are or are not linear equations in one variable.
Pause the video after hearing each question and give it a shot yourself before you listen to Bhavya's solution. Question 1.
X equals to minus 7. Clearly this looks similar to ax equals to b. So in place of a multiplied by x, we have got only x here. So where's the a? Is it missing? Well, actually we can just rewrite the x in x equals to minus 7 as 1 into x, because 1 into x is the same as x. So we've got our a. The a here is 1 on comparison. In place of b, we have got -7. But of course, a and b as constants can be positive or negative, like +1 or -7, and therefore x equals to -7 very much follows ax equals to b and is thus indeed a linear equation in one variable.
Question 2.
3y plus 4 equals to 0. Now this reminds us of ax plus b equals to 0, but we don't seem to have an x here, we have a y instead. But y is a variable just like x, so it doesn't really matter, it's the same thing, right? And in place of a, we have got 3, and in place of b, we have got 4, because the format is a into x plus b equals to 0, and our equation is 3 into y plus 4 equals to 0. Therefore, this is also comparable, and thus we show that it is a linear equation in one variable.
Question 3.
X upon 2 equals to 2. This reminds us of ax equals to b. But there's something odd going here for a, because we've got x upon 2 in place of a into x. But think of it, x upon 2 is nothing but half x, that is to say, half multiplied by x, or 1 upon 2 multiplied by x. So we can say that we have got our x, and in place of a, there is a 1 upon 2 or a half here. In place of b, there is 2 simply. Therefore, a equals to half, b equals to 2, we have got our x, we follow the format, and thus x upon 2 equals to 2 is also indeed a linear equation in one variable.
Question 4.
4x square equals to 16. Again, it reminds us of ax equals to b. Comparing both, we see that a is 4 here and b is 16 here. But there's something funny going on. We don't have an x, we've got x squared. Is this a linear equation? The answer is no, it is not. We will learn later that this 4x square equals to 16 is a quadratic equation. Linear equations have the power or the exponent to the variable as 1 and 1 only. It cannot be more than 1. Here, x is raised to the power of 2 in x squared. If exponents is something you're not completely familiar with so far, that's perfectly alright. But as long as we are all clear that x square is not the same as x, and therefore 4x square equals to 16 cannot be a linear equation. I hope you're now comfortable with the ideas of a variable, an expression, an equation, a linear equation in one variable. This might seem more theoretical and conceptual than mathematical and numerical, but I think this is an important segue into what we are going to delve into next, solving these linear equations in one variable. But until then, comment your doubts below, subscribe for more, share this with your friends. Catch you in the next one.